All right, welcome to 6.5, part 1. We're going to start solving. So we've been doing these radicals, which if you forget that word, it just means check mark. So we're going to start solving radical equations in this lesson. And we're also going to have like rational exponent ones. So that's why it says like other radical equations or rational exponent ones. So we're just going to dive in. Here's one for you to try, and I just encourage you to try it. So we're going to actually use the algebra steps method, which is where you just do the opposite operation. So pause the video and see if you can actually figure this one out. If you have the note sheet, it should be the first one right on your note sheet. Okay, so the first thing is you want to isolate this square root and cancel it out by squaring. So we're going to first add 7 to both sides to get this alone, and then we're going to square because square will cancel out the square root. So on the right hand side, we'll have 49. And then here it'll just cancel. So we'll end up with this 2x plus 3. Right? And boom, it's nice and pretty now. Right? Just minus 3, divide by 2, and boom, you got your answer. Right? So we've solved our first radical equation. Right? And so the key is we're pretty much going to use algebra steps throughout this lesson, but we just have to know what is the opposite step each time. So I think the next slide just tries to highlight the opposite part. So if you have a radical like we did on the previous one, you would cancel it out by squaring, right? But I probably should have done like a third root. So if we had like a third root of x equals 4, then we're going to do a third power to cancel that out, giving us just x and then 4 to the third, right? So whatever the root radical is, you just raise it to that power to cancel it out. Similarly, if you have a third exponent, the opposite of that will be a third root. So in this one, we take a third root of both sides to cancel out this x cubed. So it gives us x, and that'll just be the cube root of negative 27. And remember, if it's odd and negative, that still does have an answer. So we get negative 3 as our answer there. Okay, so if you have a fraction exponent, you're going to want to isolate it like it is now, and then raise it to the reciprocal power. So what I mean by that is the reciprocal is just a flipped fraction. So I want to raise this to the 3/2 power. So I have a hard time writing it in that little space, but we'll try it again. So the 3/2 power to both sides. All right, and so what happens on the right is you get x, and if I do power of a power, I would multiply them to give me 6/6. Multiply the numerators, multiply the denominators, and that just becomes x to the first, or x. Right, so it's a way to isolate x here by raising it to the reciprocal power. So x will be equal to 64 to the 3/2, which you can just straight up type on your calculator, or if you want to do it without a calculator, we can switch forms because it's a square root. This root is 2, and the power is 3, and I know what the square root of 64 is, just 8. And then that's a little hard, 8 cubed. It's just going to be, what the heck is 8 cubed? I don't know. Maybe I have to use my calculator to figure that out. All right, so it looks like it's 512. Probably should have known that. All right, so the only part that's tricky, and why I think it's not good just to rely on your calculator blindly here, is on this question we end up doing the square root of 64 right here, and that's actually both plus and minus 8. Right, so when you do an even positive, right, an even root and a positive radicand, you get 2 answers. So if we continue this pattern, we should actually get both plus or minus 512. And that's one of the hardest things in this lesson, is when do you get two answers. And if you have an even root and positive, that's how you'll know. So maybe it's better to not just use the calculator there. It's good to switch the forms and then do the steps as shown there. All right, and then the only other thing to add is, you're doing the opposite operations here, but you have to isolate it. So something like number 4 that's up here, before you do the third power here, you want to get the third root alone. So you want to add 3 and then do the third power to both sides. Right, once you've got it isolated, then do that, and then we get x equals 5 to the third power, so 125. And that's just 125, right? 5 cubed is not negative 125. It's just 5 times 5 times 5. So 125, just a single answer there. All right. So the rest of this is just practice problems. I encourage you to pause the video and try each one, especially this one. I'm hoping at this point you have a pretty good shot at getting this. So we got to isolate this square root first before we do anything else. So minus 3. All right, now that it's alone, we're going to square both sides so that the square root cancels out, and we're left with just that part. So 2x minus 3, and 5 squared is 25. Now add 3, divide by 2, blah, blah, blah. We got 14 as our answer for x. Right, and if we're not sure about our answer, maybe you don't trust your teacher or something like that, you can always put it back in, right, into the original equation and see if it makes a true statement, right? And this one should check out, but you can always do that if you're not sure. All right, let's try a fraction exponent 1. Pause the video, give it a shot. All right, so we are going to use the reciprocal power, but this is our base exponent. So before we do anything else, we want to get that alone by dividing everything by 3, right? So that we have the base, which is x plus 1, to the exponent of 2/3 isolated. All right, now do the reciprocal. So we're going to do the 3/2 power. Okay, and again on the right, you're going to get 6 over 6 when you do power of a power here. And that's just going to be 1. So essentially it wipes it out. All right, so on that side we have just x plus 1. I don't really need the parentheses at this point. I'm not sure why I wrote them. It's x plus 1 to the first. And then on this side I'm going to switch forms. So I'm going to have a square root of 4 to the 3rd power. All right, and then square root of 4. This is the tricky part because remember it's both plus and minus 2. And then when you cube it, you get plus or minus 8. All right, so x plus 1 can either be positive 8 or x plus 1 can be negative 8. And if I solve both of those, minus 1 here, minus 1, right? So you get 2 answers of 7 and negative 9. Sorry, my computer freaked out there at the end. Just negative 9. All right, and so the tricky part on this one, kids always forget, is because we took a square root, we have to do plus and minus. 2 answers to an even positive. All right. Pause the video, give it a shot. All right, so first thing is we got to isolate this mess. So I'm going to minus 1 and then divide by 3. So maybe I'll do it in 2 steps. That's a lot of writing, but what the heck. I want to give you the quality education you deserve here. So minus 1, then divide by 3 to get the radical part alone. All right, and a lot of people here like to switch it to a fraction exponent, which is perfectly fine. But what I kind of do is I just like to do it this way. Say, well, it's a 5th root, so I'm going to do a 5th power to wipe that out, right? And that wipes out the root part. So I just have x plus 1 cubed equals 8 to the 5th, right? And 8 to the 5th is a pretty big number. And now I'm just going to cube root both sides to cancel it. And again, I'm going to be thinking in my head here, am I going to get 1 or 2 answers? Hopefully, remember odd roots, right? Odd roots just have 1. So I'm going to get x plus 1. It's going to wipe out this little cube. And I'm only going to have 1 answer on this side. Just cube root of 3200, 768. Okay, so do the cube root on my calculator, and I get 32. And then just minus 1. And boom, we have our single answer, right? So you don't always get 2 answers. It kind of just depends. You have to think through the question. All right, final thing I think for today's lesson is there's something called an extraneous solution, which you do see this on standardized tests like the ACT or the MCA and stuff. And so what extraneous solution is like you get the answer for x, like x will equal 2 or something, but when you plug it in, it doesn't actually work, so it doesn't count as an answer. All right, so that can happen on these questions. It's not the super focus of this lesson, to be honest, but I thought I'd at least mention it because it's something you might see on standardized tests. All right, so definitely jot this one down, and the solving steps for this are a little different than what we did before. If you want to try it, go ahead. Okay, so I'm going to start by isolating my square root. So add 5 to both sides. Okay, and what's different here is when I square, right, I want to square to cancel out the square root. On this side, you got to be careful, right? Most kids get that the left-hand side is just x plus 7, wipes out the square root. But on this side, it's not x squared plus 25. Okay, and the reason is you have an x plus 5 times another x plus 5. Right, and usually when I write it this way, kids can figure it out, right? That at this point, the right-hand side, we got a FOIL. So we're going to have x times x times positive 5 times x, and positive 25. Right, so we do have x squared and 25, but we also have 10x in the middle. If we combine our like terms here, we have a 10x in the middle. All right, so now this is something I hope you really, really get out of Algebra 2 class, which is now we have an equation that has x squared and x, right? And so I don't really want to do the algebra steps method to solve this anymore. All right, when you solve an x squared, right, see if you can remember what are our methods from solving x squared, right? We did this a bunch in chapters 4 and 5. Okay, so your methods are, you can always do quad formula. You can try to factor it apart, or you can use the graph method, where you graph it and find the x-intercepts. Okay, any of those methods, we need 0 on one side, so I'm going to do that next by minus an x and minus a 7. So 0 equals x squared plus 9x plus 18. All right, and then again, if you love quad formula, knock yourself out. All right, but generally factoring, these ones should factor and they'll be pretty easy. So we use x and x to get the x squared, and then it has to multiply to 18 and add up to 9. So if we think of our factors of 18, 1 and 18, that doesn't work. Let's see, 2 and 9, that doesn't work, but 3 and 6 does. So we do plus 3 and plus 6, right? And then set those two parts to 0. And so we get x equals negative 3 and x equals negative 6. So sorry I couldn't quite fit that whole thing on the screen, but there's our two answers. All right, so that's a pretty complex, advanced question. All right, so involves some FOILing, some factoring, and you got to know how to solve an x squared. All right, so the final part then is this says check your results. So what we're going to find is we do have two answers currently, but one of them doesn't count because if we put it in, it won't work. All right, so the next spot on the sheet, this is the same equation, and we got our two answers here. But if we check, right, if we check negative 3, so I'm going to put negative 3 in for both spots for x. So negative 3 plus 7 minus 5, we want that to equal negative 3. So this would be the square root of 4 minus 5. And we're saying, hey, I should put a question mark here because we want to see does it equal negative 3. And 2 minus 5, that does equal negative 3. So this guy counts. This is a good solution. Right? Negative 6, if we try that, negative 6 plus 7 minus 5 equal negative 6, question mark. So we'll have the square root of 1 minus 5, and we'll say, hey, does that equal negative 6? And so we'll get 1 minus 5, and that is not equal to negative 6. So this is called like an extraneous solution, and we kind of put a line through it and say it doesn't count. All right, so that's like a pretty advanced concept. Might be tested, I'm not sure, I don't remember, but again, you just put in the check, and since it didn't work out, right, negative 4 is not equal to negative 6. It does not count as an answer. All right, thanks for watching.